We're going to have a look at measuring bearings, and there's a few little tips to follow. So for the first question, it's measuring the bearing of point I from point F. Now, if we're measuring from F, and from is the key word, then F is where the center of your protractor has got to go. The next thing to take into account is that north is always 0. So 0 degrees on your protractor is lined up with north. And the third tip is that with bearings, you always have to measure clockwise. So you're starting from the north line at 0, and then you're measuring around clockwise until you hit the line. So you follow those 3 tips: the center of your protractor on F, and not the letter F, on the actual corner of the angle next to F, because F is just a label. Your protractor 0 is lined up with north, and then you count the numbers starting at 0 clockwise, 0, 10, 20, and so on. You should get, for your first answer, 75 degrees. Now, there's another thing to mention about bearings, and that bearings always have 3 numbers. So if you get something like 75 as an answer, you actually need to write 075. Now, they need 3 numbers like that because these are designed to be given as directions in, perhaps dangerous places. So, for example, you've got a ship in the middle of the sea, there's howling winds, there's rain, it's really bad weather, and you're radioing out your position in some kind of emergency. So, if someone just hears 7 down the radio, they're going to go 7 degrees. But what if the message cut out and it was actually 075? So if someone hears a message with bearings in and there's only 1 or 2 numbers, they know for sure they've missed part of the message and they can ask for it to be rebroadcast. So there have to be 3 numbers in bearings, even if some of them are just filler zeros. So moving on to question 2, keep 3 tips in mind. We're measuring from C, so the center of a protractor is on the center of the angle next to C. We're measuring from north, which is 0 degrees, and we are measuring clockwise. We are starting at the north line. We have to go clockwise and going all the way around to line E. Now, some protractors will actually measure 360 degrees, the big circle protractors, and that might make things easier for you. But a lot of protractors only have 180 degrees. So here's what you do if you only have a 180 degree protractor and you can't measure an angle that big. What you can do is measure anti-clockwise and get a number for that. And measuring anti-clockwise, you should get 72 degrees. Now, the way to get the clockwise measurement then is to take the full circle, 360 degrees, take away the anti-clockwise measurement, 72, and if you work that out, you should get 288. So if you take the anti-clockwise measurement from the full circle, you will get the clockwise measurement. And so writing down the answer, 3 digits, 288. Moving on to question 3, now we're starting to lose pieces of information from the diagram. So we're still measuring from something, we're measuring from F. So the center of our protractor is going on F. Our north line's still labelled, that would be 0 degrees, and that's where you put 0 on your protractor. But what's missing now is the angle, and it's just testing that you understand that you need to be measuring clockwise, and you're measuring the large angle here. Now, while we're trying to find the large angle, you can measure the small angle anti-clockwise to help you, like we just did. So you take the full circle, 360 degrees, and you need to take away that anti-clockwise measurement. Now, for that, I'm getting about 13 degrees. So if we take 13 away from 360, we'll get that large clockwise measurement, which is going to be about 347 degrees. So as a bearing, 3, 4, 7. Now on question 4, we have even less information on the diagram. Now we are measuring from point X, so let's highlight that. But now there's no north line. Now there's no north lines, it's quite common. You're going to have to draw one yourself. So you need to get a ruler and draw a north line as straight as possible and also as vertical as possible. You can label it north, And again, that's going to be at 0 degrees. As a bearing, 0 degrees would be 0, 0, 0, by the way. This is always going to test that you know which way to measure. We always start at the north line, and we always go clockwise for a bearing. Now, the measurement you should be getting there is about 46 degrees. Now, I thought it's probably in between 45 and 46, that one, to be honest. But what will happen with measurement questions is you will be allowed a few degrees on either side. So it very well could be 45, but 46 would be absolutely fine as an answer as well. But make sure it's a bearing. We only have 2 digits. So fill in any blank spaces with a 0 until you get 3 digits. Question 5 works the same way. So we're measuring from point M. Highlight it. We have no north line. We need to draw our own. The north line's drawn from that point we're measuring from. So it's from M, it's not from C. And then we need to be measuring clockwise. So again, we've got a large angle. So if you don't have the protractor for it, instead measure the small angle the other way, the clockwise angle. So take the full circle, 360. We're going to take away the clockwise angle, and I'm getting about 40 degrees for that. So we're going to take away 40, and that should give us 320 for the large angle. So for our answer, that would be 320. And again, with a 320, just think about how transmissions might be cut off. If the last digit is left off, you'd have 32, which is 32. And that is a completely different direction to 320, which is 320. So again, very important, you have the 3 digits. And it might be worth writing some revision notes down for this. So for bearings, they are almost the same as angles, but you have 3 digits. You might hear that referred to as 3 figures instead. You start at north with your measurement, and you always measure clockwise. It's designed to give really accurate information, kind of over a transmission in a dangerous place where there might be a lot of noise, a lot of interference. You don't want to say 23 degrees anti-clockwise. You just want to say 0 to 3, and everyone knows it's a clockwise measurement. Now, you're not just going to be measuring bearings, you'll do calculations with bearings as well. So, for example, the medium questions, all of these bearings, we have some angles drawn already, but we're calculating bearings from Y. So it's going to be useful just to highlight where the bearing's actually being measured from, because at first glance, you might think it's about that X, and it might be 73 degrees as an answer. Now, since we're measuring from Y, we need a north line at Y. So this diagram is going to have its second north line. And we need to remember that bearings are always measured clockwise from north, which is 0. So we want the angle I'm now drawing on in green. Again, a lot of students might be tempted to write down 73 as an answer, but that 73 is measured from X. It's not measured from Y. Now, although we want that clockwise measurement, the anti-clockwise measurement can be very helpful as well, which I'm drawing on in purple. Now, there is a connection between the purple anti-clockwise measurement and the 73 degrees that the diagram started off with. And what that connection is the north lines are parallel because they're both pointing north, and they're joined up. And what you should be seeing is that we have a C shape on its side. If you remember your parallel line angle facts, C shapes stood for co-interior angles, and they add up to 180 degrees. So if we take 180 degrees, which both angles add up to, we take away the 73, what we are going to get is 107 degrees. And so 107 degrees is that anti-clockwise measurement. And so if we have the anti-clockwise measurement, we can take it away from 360 to get the clockwise measurement. And what that should give us is, and we can use column method for this because it might be non-calculator paper. So let's borrow one. 10 take away 7, 5 take away 0, and 3 take away 1. We're getting 253. So what is the bearing? It's bearing 253. Moving on to question 2, we are also finding the bearing from Y. So our first job is to make a brand new north line. Then we're going to draw on the angle we're going to try and find, starting at north, going clockwise. So again, I think that anti-clockwise angle is going to be important here. So again, we always are going to have a pair of parallel lines here. Every single north line is going to be parallel. And we join up those parallel lines, again, we've got another set of co-interior angles. Again, that kind of set of parallel lines joined together that makes kind of a C shape, co-interior lines. So we have 180. If we take away the 135 we'll be given in the question, that's going to give us that anti-clockwise angle. And so that is going to be 45 degrees. So the anti-clockwise angle is 45 degrees. If we take it away from the full circle, 360, these are easier ones. We just do these in our head. That should be 315 degrees to get up to 360. So let's label that 315 is our bearing. Moving on to question 3. Again, we're measuring from Y, and we're going to need another north line, this time from Y. So let's identify the angle we're trying to find. Start at north, and we are going clockwise. And it's actually quite a small angle this time we're trying to find. So again, I think some kind of angle facts can help here. So let's identify our parallel lines, the two north lines. Now, if we join these up to get co-interior angles, we don't actually have any angles inside this to help us. This time the angle's on the outside. But one technique we can use is we have that 195 degrees. So half of that is a semicircle, 180 degrees. And so the little bit that's left over on the outside there, that is going to be a 15-degree angle. And now I'm starting to see another one of the parallel line angle facts. So let's draw on another angle there. Now it's quite close together, so it's hard to see. So I'm going to draw this in a bit more detail at the top. We have the angle we're trying to find, and then we have the angle that we've just worked out, which is here, which was 15 degrees. Again, we know that's 15 degrees because if we go all the way around, we've got 180 and we've got a 15, which together is going to give us 195. So thinking back to kind of parallel line angle facts, this kind of makes a Z shape if you kind of look at it on its side. And I'll just highlight that. Again, we've got the parallel lines and join them up, and it's a Z shape on its side. And the word for that was alternate angles. Alternate angles are equal. So we can say that if one of them is 15 degrees, the other one is also 15 degrees. And as a bearing, we can't write 15, we have to write 0, 1, 5. So since we're using more than one parallel line angle fact, I've just put the two we're using up at the top as revision notes. And moving on to question 4, again, we're measuring from Y. So we're going to put the north line down from Y. Again, not from the letter, but from exactly where the end of the line is next to it. And then we're going to label the angle we're trying to find and then figure out what to do. So clockwise from north. Now, again, I think we might be getting here another co-interior angle. We have our parallel lines. Let's highlight those, join them up. And if we did find the anti-clockwise angle here to the original angle we're given, we're going to have a pair of co-interior angles. So the original circle is 360 degrees. We're going to take away what we started off with, which is 267 degrees. So let's borrow one and calculate. 10 take away 7. 5 take away 6. Let's borrow another one. Right, 15 take away 6. That's better. That's 9. And 2 take away 2 is 0. So we have 93 degrees. And the 93 degrees, that is the anti-clockwise angle. That's co-interior with the one we're trying to find. So co-interior angles add up to 180 degrees. We're going to take away the clockwise angle we just found, and that should give us 87 degrees. And that is going to be the angle we're looking for. So the 0, 8, 7. Moving on to question 5, we are measuring from point Y. So we'll need a north line from point Y. Identify the angle we're trying to measure, starting at that north line, and it's going to come down here. And then just highlight your parallel lines and join them up and have a think about which angle fact might be helpful here. And again, I think this will be a case where the kind of the anti-clockwise angle is going to be helpful for us. So, like the last question, the original circle's 360 degrees and the labeled angle is 346 degrees. That'll give us the anti-clockwise angle, which should be 34 degrees. If you're not sure, do a full column method. That's going to be co-interior with the angle we're looking for. So 180, take away what we have, will leave us with what we're looking for. And that's going to be 146 degrees. So 146. Moving on to the hard questions, we now have some more complex problems involving bearings, but these are not necessarily involving as many bearings as you'd think. So we have a train that's driven 75 kilometres on a bearing of 133. We want to know how far south it's driven. So if we think about this, if it is starting this train at the point, I'm just highlighting in blue, just labelled 0, and it's moving to point T, so it's from point O to point T, the distance south is going to be the dashed line I'm drawing. And the distance east it's travelled is going to be the second dashed line. And it's forming a triangle. And so this is all going to be about solving this triangle. So let's draw it out a little bit larger. So for question 1, I'm going to sketch a triangle. Doesn't matter about the dimensions as long as the labels are correct. So let's label what we have. So we know that we have a side that's 75 kilometers. We know that between kind of south and east is going to be a right angle. So we've got a right angle triangle. Now, could we work out another angle? So what about the angle here? Well, the bearing we've been given starts at north, and clockwise it goes 133 degrees. So if it continued back to the north line, that's going to give us a straight line. So the 133 and the angle I'm looking at now together are going to make 180 degrees. So 180 take away 133 is 47. So the first thing is we know that's a 47 degree angle. The next thing is, which side are we actually looking for? We're looking for how far south we've travelled. So it's going to be the vertical line we're looking for here. Now, what we have set up is a trigonometry question. So we use a little bit of bearings to get that 47 degrees, but the rest of it is trigonometry. So go back and watch the videos on finding missing sides using trigonometry before you carry on. I will give a quick overview though. So we need to label our triangle. So the longest side that's opposite the right angle is a hypotenuse. The side that's next to the labeled angle and the right angle is the adjacent. And so if we have the hypotenuse and the adjacent, we can write down SOHCAHTOA and we'll look at which one has got A and H, and it's car. So we want to draw the car formula triangle. From left to right, C, A, H. We are looking for A, so let's cover it up. And that leaves us with C and H next to each other. And if they're next to each other, it'll be a multiplication. If they're on top of each other, like with the A and the H, or the A and the C, it'll be a division instead. So we're going to do cos 47 multiplied by the hypotenuse 75. And if you type that into your calculator, you should get 51.1 kilometers. Moving on to question 2, let's try the same process. So firstly, we need to form our triangle. So we're looking at a ship. It sailed 75 kilometers. It started at O and it ended at S. We want to know how far east it sailed, but it's also gone south. So let's sketch that triangle. Again, I'm not paying too much attention to this size and shape of it. It's just pointing in the same direction, and it'll have the same labels. So we have 75 labelled on it. And at the moment, we don't have anything else. I guess we know it's a right angle. And we're looking for how far east it's sailed. So that's going to be this side. So it's going to be helpful to find the angle again. Now, the bearing is 118, staring at north and reaching that line. So then the rest of that back to the line is going to make 180. So 180 take away 118 is going to give us 62 degrees. And again, that's the limit of the bearings we'll be using here. Now it's a trigonometry question where we have a hypotenuse. This time we don't have the adjacent next to the labelled angle on the right angle, but we do have the opposite that's opposite the labelled angle. In SOHCAHTOA, SOA has got O and H in it, so we're going to draw the form of the triangle for SOA. From left to right, S, O, H. If you're not sure about this, go and watch the video about it first. We're looking for O, cover it up, and we've got S and H next to each other. So it would be the sin of 62 multiplied by 75. And if you type that into your calculator, you should get 66.2 kilometers. Moving on to question 3. Read the question first. A jet has flown 80 kilometers. It's flown from point O to point J. Now, we need to try and make a triangle here. Now, we want to know how far north it's flown. So if it's flying north, it must have started at J and gone to O. So the kind of way it's gone isn't really too relevant. So it started at J and gone north, then it also must have gone to the east. Now, a quick little point here is that you could draw a triangle going north first and then east second and have a triangle the other way around. But to help with the bearings, I'm making sure that my north and south lines are lined up with a north line given to me in the question, which will make it a lot easier. So always try and do it that way around. So let's sketch the triangle. So it's pointing the other way around this time. So it's important to show that. We know the hypotenuse is 80. And again, we're going to have to try and find the angle at the top. Now, the bearing we've been given is 214, starting at north, going all the way around. Now, we've got 180 degrees there, and it carries on a little bit further to get the 214. So, to find the angle we're looking for, if we're going 180 degrees and then a little bit further, 214 take away 180 is going to give us 34 degrees, and that's actually the angle we're looking for. So going back to the original diagram, there's 34 degrees and the 180 degrees in a straight line. Together, they make up the 214. So it's not always the same method for finding your angle using bearings. It kind of depends on kind of what quadrant of the circle we're looking at. Going back to the question, we're looking for how far west we've flown. So that's going to be that side at the bottom, where the other side would be north and south. So that would be the opposite. We had the hypotenuse. So this is going to be another SOA question. We're going to multiply sin of the angle by the hypotenuse. And if you type that into your calculator, you should get 44.7 kilometers. Moving on to question 4. Again, read through the question and identify what's going on. So we have a jet, it's flown north. So it must have started at point O and it's finished at point J. So when we're drawing our triangle, we want to know how far north it's flown. So from its starting point, we want to follow north up to here. And then how far east is going to be relevant as well. So again, we've got a kind of another orientation of triangle here. Let's draw it out. Little sketch. We're going to have our right angle, and we know it's gone 95 kilometers. So it's going to be helpful to find the angle here that's coming off the north line. Now, the bearing is 34 degrees, starting at the north line and coming to our line. Now, that is actually exactly what we're looking for. So there's no calculations here. It's just the bearing. It's 34 degrees. We are looking for how far north we've flown. So let's label that. Now, how far north is gone? That's the adjacent. It's next to the right angle and the labelled angle. And the distance 95 is the hypotenuse again. It's the longest side. It's opposite the right angle. Out of SOHCAHTOA, A and H is in car. Draw the pyramid. C, A, H from left to right. Go for what we're looking for. We're looking for the adjacent. So we have C and H left. Then next to each other, it'll be a multiplication. So it's going to be cos of the angle multiplied by the hypotenuse. And typing that into your calculator, you should get 78.8 kilometers. Now looking at the final question, question 5. Again, we're going to identify what's going on first. We have a train. It's driven north, so it must have started at point O and finished at point T. If the journey north is important, so let's label that, we're going to be going west as well. So there's our triangle. So let's sketch it. Label the right angle, and we know it's gone 40 kilometers for the hypotenuse. Now we're looking for how far north. Let's label that. And again, we're going to want an angle. It's not going to be the angle over here, because that angle, it's not connected to the north line at all. So it's not going to be helpful to find that. What we need to do is find the angle that's connected to the north, because we're away using bearings to figure that out. So looking at our bearing, starting at north, we've gone 321 degrees around. And what we want is a little angle that's missing out there. So that's kind of like the clockwise angle. So we take 360 for the full circle, and we take away the 321 degrees. What we should get is 39 degrees for that angle. And then we can label what we have. So we have the adjacent, we have the hypotenuse. So that's going to be another car question. So using the same form of triangle, it will be cos 39 multiplied by 40. And on a calculator, that should get 31.1 kilometers.